In level 3, we will be doing two different things. One is to algebraically find the inverse of a function, and the other is to determine whether two functions are inverses of each other. And these kind of involve different methods, so we'll start with the first part, finding the inverse of a function. And to do that, you will interchange x and y and solve for y. So you're just going to switch the x and y in an equation and solve for y. Okay, looking at this first function, instead of f of x, I'm going to write y equals 2 square root of negative x plus 4. And then we literally switch the x and the y. So I replace y with x. I replace x with y. And now I have to solve for y. So to get y by itself, I would subtract 4 from both sides. And we get x minus 4 equals 2 square root of negative y. And next I would divide by 2 on both sides. And we get x minus 4 over 2 equals square root of negative y. And then we would square both sides. To cancel out the square root. And we get x minus 4 over 2 squared equals negative y. And then we almost have y by itself. We have to just divide by negative 1 on both sides. And so we get y equals negative parenthesis x minus 4 over 2 quantity squared. And now our last step, instead of writing y, we're going to say f inverse of x equals negative quantity x minus 4 over 2 squared. And that's the inverse function. Now, it's also important to think about the domain and range of a function and its inverse. So let's talk about that real quick. The domain of f of x is everything x can be. So if we think about the possible x values that we can plug in here for x, I need to have a positive number under the square root, so I'm actually going to have to plug in a negative number to make the inside of the square root come out positive because of that negative sign. So the domain of x, or of f of x, is x has to be less than or equal to 0. Or you could write this in interval notation, negative infinity to 0. Okay, then the range of f of x are all the possible y values that we might get. So if we think about the smallest this radical could ever be is if I plug in 0. If we plug in 0, we get 2 times 0 plus 4, which equals 4. So the smallest y value I would ever get for this function is 4. I could plug in bigger bigger negative x values would come out to bigger positive values. So those will get bigger and bigger. We can have y values greater than 4, but the biggest y value we would ever have is 4. So the range of this function is y has to be greater than or equal to 4. And we could also say that in interval notation. Oops, I didn't mean to write 0. I meant 4. So we could say 4 to infinity. Now, the domain and range of the inverse function always just switch places. So the domain of f inverse of x and the range of f inverse of x they just literally, we take these the domain and range of f of x, and we switch them around. So the domain of f inverse, instead of using y, we would say x is going to be greater than or equal to 4, or we could say 4 to infinity. And the range of f inverse is going to be the domain of f of x, but of course we're going to use y for range. So y is less than or equal to 0, and we could also say negative infinity to 0, which should have been a bracket up here too. And this. Okay, and this should also be a bracket. Okay, we're going to look at one more example where we're finding the inverse. This function is a parabola, but it gives us a domain restriction that x is greater than or equal to 2, because otherwise it wouldn't be a one-to-one function. If you think about what this function looks like, it is a parabola that's shifted 2 units to the right and 5 down. So over 2, down 1, 2, 3, 4, 5. But the function is only defined when x is greater than or equal to 2, so it's only going to be that one side. And then the domain for this function, we could start there. It's already given to us. That is x is greater than or equal to 2. Or we could say in interval notation, 2 to infinity. The range of this function is all possible y values. If I plug in my lowest x value of 2, that gives me the lowest y value, which would be negative 5. So the range is y is greater than or equal to negative 5, or negative 5 to infinity. And before we even find the inverse function, we can determine the domain and range of the inverse by just switching these around. The domain of g inverse comes from the range of g of x. So domain is x values, so we say x is greater than or equal to negative 5, or negative 5 to infinity. And the range comes from the domain of g of x. This should say g inverse. And we get y is greater than or equal to 2, or 2 to infinity. And finding the inverse of, or the actual inverse function, remember, instead of g of x, we write y equals x minus 2 squared minus 5. And then we switch x and y. So I write x here, y here, and we solve for y. So I would add 5 to both sides and get x plus 5 equals y minus 2 squared. Next I would square root both sides to get rid of the square, and I have to remember to put plus or minus on this side. The square and the square root cancel. Now, the plus or minus, we would normally put plus or minus, but in this case, since we are reflecting, or we're only using half of this graph, we're using the positive half and reflecting it, and we'll get a graph that looks something like this. We're only going to keep the positive case for this, so we actually aren't going to keep the plus or minus. We're just going to use square root of x plus 5 equals y minus 2. And then we would add 2 to both sides, and we get y equals square root of x plus 5 plus 2. And our final answer, we replace y with g inverse of x equals square root of x plus 5 with a plus 2 on the outside. Now the next part, the next goal of this level is to determine whether two functions are the inverse of each other. And to do that, we're going to use composition of functions. And if two functions are the inverse of each other, we have to show that f inverse of f of x equals x and f of f inverse equals x. So what we're doing is we're plugging f of x into f inverse, and then we plug f inverse into f of x. And if both times we get just x, positive, regular old x, then they are the inverse of each other. Okay, in this example it says show that the functions f of x and g of x are inverses of each other. So what we need to show is that f of g of x equals x and g of f of x equals x. So we have to show both of these. Okay, so we're going to start with this first part, and we plug g of x into f. So we get 1/2 parenthesis, I replace this x with this function, and we get cube root of 2x minus 12 plus 5. And then we have a minus 5 from here, cubed plus 6. And then we simplify. The plus 5 and minus 5 cancel. So we get 1/2 cube root of 2x minus 12 to the third plus 6. The cube root and the cube cancel. So we get 1/2 times 2x plus, oops, that was minus 12 plus 6. We distribute the 1/2 and we get x minus 6 plus 6. The minus 6 and plus 6 cancel and we just get x. So we showed the first half. Okay, now we're going to show this second part, that g of f of x equals x. So now we are plugging this function into that x. So we get the cube root of 2, and then I replace that with 1/2 x minus 5 to the third plus 6. And then we have a minus 12 and a plus 5 on the end. Okay, so I start simplifying. First I'm going to distribute this 2 to both of these terms, and we get the cube root of, well, the 2 and the 1/2 will cancel, and we'll just get x minus 5 to the third and then 2 times 6 is plus 12, and then we also had a minus 12 underneath this radical. The plus 12 and the minus 12 cancel, and we get cube root of x minus 5 to the third, the plus 5 on the outside, and then the cube root and the cube cancel. We get x minus 5 plus 5, the minus 5 and plus 5 cancel, and we get x. So we showed the other direction. So that's what we have to show to prove that they are inverses of each other. So we could say, so f of x and g of x are inverses.